Assalamualaikum warahmatullahi wabarakatuh to my evaluator, Dr. Siti Asmani and Dr. Siti Alia. My name is Muhammad Afiq bin Jamaluddin and I will be presenting my final year project entitled The Utilization of Mineral Admixture as Partial Cement Replacement in Production of Eco-Friendly Concrete. My metric number is 1626763 and my supervisor is Dr. Nadia Mahusin. This is the outline of my presentation, which starts with introduction and it continues with literature review, methodology, result and analysis, and finally the summary of my works. For the introduction, there are two problem statements in my research. The first one is the emission of carbon dioxide due to the usage of cement in concrete production. And the second one is waste disposal problem caused by massive production of fly ash. There are also two objectives in my research. The first one is to determine the mechanical and physical properties of concrete with fly ash and natural zeolites as partial cement replacement. And the second one is to investigate the optimal portion replacement of fly ash and natural zeolites with cement in production of concrete. This is the table of comparison from past research in my literature review. As we can see, there are several researches that were conducted before which incorporate fly ash and natural zeolites with other materials as partial cement replacement with different amount of materials. From their research, it shows that fly ash and natural zeolites can be utilized in replacing cement content partially. This is the flowchart that will be followed throughout this project. Four materials will be used in this research, which are coarse and fine aggregate, cement, fly ash, and natural zeolites. Both coarse and fine aggregate will undergo sieve analysis to determine their particle distribution, while only coarse aggregate will undergo Los Angeles abrasion test to determine its abrasion resistance. The mix proportion for this project is calculated in concrete mix design using DOE method. After mixing process, the samples will undergo two fresh concrete tests, which are slump test and compacting factor test. Then, the concrete will be left hardened for 24 hours in cube mold and it will continue with curing periods for 3, 7 and 28 days. Finally, all samples will undergo hardened concrete tests, which are UPV test and compressive strength test. Okay, so this is the mix proportion that have been calculated in concrete mix design using DOE method. There are three mixtures in this project, which are mix A with 0% of fly ash and natural zeolites, mix B with 5% of fly ash and natural zeolites, and mix C with 15% of fly ash and natural zeolites. The water to cement ratio is kept constant for all mixes, which is at 0.55. Now we go to the result and analysis. There will be two aggregate tests, which are sieve analysis and Los Angeles abrasion test. Then there are two fresh concrete tests, which are slump test and compacting factor test. And finally, there are two hardened concrete tests that will be conducted, which are UPV test and compressive strength test. Now we start with the result of aggregate tests. This is the results for sieve analysis, which involving coarse and fine aggregate. The test was done for the total amount of aggregate that will be used in this project. The trend for both grading curves shows an increasing trend, which explains the aggregate used are well graded and varies in sizes. According to Power et al. 2016, a well-graded aggregate used in concrete will fill in the void between the larger size aggregates, and hence it creates a high strength of concrete. Next, this is the results from Los Angeles abrasion test. There were two samples that were used in conducting this test. The average result from both samples is 26.90%, which have passed the number 12 ASTM sieve. According to Coelho et al. 2007, the maximum value for Los Angeles abrasion test is 40%, and any value that is less than the respective value is considered as durable. Aggregate that is used in concrete with high abrasion resistance, which will result in high compressive strength. This is supported by Dong et al. 2013, which stated that Aggregate with high abrasion resistance will produce a high strength of concrete since the aggregate is durable and strong to cater the load applied on the concrete. Hence, the result from both aggregate tests shows that it is suitable to be used in this research. Now we move to the results of fresh concrete test. This is the result from slump test. As we can see, the results for all slump value are not high as expected since the target slump in this project is 100 mm. For mix A, which 0% of fly ash and natural zeolites, the slump value is only at 28.3 mm. Then it drops to mix B for the slump value of 26.8 mm. This is because of the properties of natural zeolites that affect the value from this test. According to Coelho and Fowler 2003, natural zeolite is a porous material which it will increase the water demand of concrete mixture as the water is absorbed into its internal pores. From the graph, we can see that the result for mix C, which contains 50% of fly ash and natural zeolites, starts to climb as the increasing of fly ash that helps to improve the workability, as well as longer time for manual mixing, which allows water to seep out from the materials and producing a wet mixture. This is the result from compacting factor test. The result is compared with the slump test to measure the workability of concrete by following the table of comparison which taken from past research. As we can see, the highest ratio is 0.91 for mix A and the lowest is 0.88 for mix C. The value is referred to the table on the right side, and the workability of concrete falls into low workability category. The result from this test shows that the ratio is considered as normal according to the standard use. This is supported by Mukherjee et al. 2013, in which the normal range of compacting factor lies between 0.8 to 0.92 in accordance with the BS standard used for this test. Now we move to the results of hardened concrete test. This is the result for UPV test. The result from this test is compared with the table from the right side, which is taken from the past research to measure the class of concrete. As we can see, the result shows a decreasing trend for all samples. This is because of the properties of fly ash and natural zeolites, which affect the value of this test. According to Ranjbar et al. 2013, the result from the UPV test is because of the slower rate of pozzolanic reaction between the fly ash and the cement hydration products. This is also supported by Ne'matzadeh and Por Hossain 2017, in which natural zeolite is a porous material which allows the ultrasonic wave to pass through its structure and resulting in low velocity from UPV test. Even though the mineral admixture affect the result from the UPV test, the concrete still falls under good class of concrete. Finally, this is the results from final test in this project. From the result obtained, the concrete strength for all mixes increased significantly through all three curing periods. This is because of the incorporation of mineral admixture in the concrete mixture. This is supported by several past researchers with which fly ash and natural zeolites contain high pozzolanic activity, which results in high chemical reaction during hydration process, and it able to increase the strength of concrete. However, for mix C, which have 15% of fly ash and natural zeolite, the result shows that it did not meet the target strength for 28 days. While mix B, with 15% of fly ash and natural zeolite, shows an impressive strength development and met the target strength for 28 days, as well exceed the strength for control sample. Hence, in this project, it is believed that the optimal portion to incorporate fly ash and natural zeolites are 5% each, and it is believed the strength of concrete will be increased by using the optimal amount of mineral admixtures as partial cement replacement in the concrete. In conclusion, The objective of this research are determined. The mechanical and physical properties of concrete with fly ash and natural zeolites as partial cement replacement are discovered by all the tests that have been conducted. Concrete with mineral admixtures as partial cement replacement are proved to improve well in its properties, and it can be an alternative to produce an eco-friendly concrete. The recommendation for this research to obtain a better results are: the water to cement ratio should be adjusted according to the quantity of fly ash and natural zeolites to increase the workability. Next, and finally, the fresh concrete test should be done quicker since it is carried out outside of the lab with high surrounding temperature to avoid the mixture hardens quickly. Okay, that's all from me. Thank you.